Hello everyone and welcome to our new video regarding the latest PC-3000 software update 7.9. In this video, me and my colleague Sergey will tell you about the latest innovations in our software, and we will tell you which new features appear and what kind of features you will need to use to solve the most burning problems appearing in hard drive and SSD sphere. So at this moment, I'm going to pass my word to Sergey. He will start with the hard drives, and later I will continue with SSD part.
Hello everyone, Sergey is here, and today we want to speak about new version of PC-3000 7.9. And as usually, we want to give you a quick review of new updates and features which appeared in the software. And we will start from the HDD. I want to show first of all example which will be about Seagate F3 Utility. I will use this Rosewood drive, and I want to show you one interesting thing which you can use on practice. So I'm plugging the drive to the PC-3000, connecting the terminal as well, and sharing the screen with you. So port number 0 is selected. And what about this case? After the power on, drive get ready state. If I press auto detection or if I do any other action, I can see that drive gets to the state with DWF enabled. Drive write fault register is enabled, so right now it's not possible to initialize the drive, and of course it's not possible to read the user data. This issue is not new. We already created a blog article about it a few years ago, so probably you remember that to solve this issue, it was necessary to initialize the drive through the terminal. It was necessary to use disk firmware container 20D system file and bypass the problem through the special option. It's the long way, and in this video I want to show you what exact new we have for such case. What I'm doing, I'm starting the correct family, it's Rosewood A5. Right now drive is still not locked. It's still not patched, I mean. So after power on, you see that there is no ability to unlock the drive. And many times we have questions in technical support about the new multiple patch system. Yeah, because previously to patch the drive, we had to use this option. And what about now? I want to show you the new way, and also want to discuss the possible options which we have right now. So I'm going to work with flash ROM. I will read the ROM through the terminal. Okay, so I'm creating the backup profile folder. And actually this is the opened original ROM. You remember that previously to start work with the drive, it was necessary to use the correct patch. And for now, because of there are a lot of different families of Seagate drive, we have 4 different patches. Yes, sometimes it's not really easy to understand what exact patch you should use. That's why our developers created this new system, which is called Technomod multi-patch. And when you use this option. You don't need to think about what kind of patch to select from the list. And moreover, what's most important, you can also add special, very important and useful options here. What kind of option? For example, you can use write protection. Write protection previously was possible also to set through the disk firmware container, but right now you can permanently block the writing using this option. And actually it's very important, for example, for such cases when you use donor heads and when writing could be dangerous for the drive, it could be recommended to block the writing. But of course you should understand that after that you will not be able to change anything inside the service area. That's why be careful with it. Also, in this case, as you remember, at first we had DWF register, which means device fault state. And the option to skip device fault state is also available right here. That's why additionally to the patch, I can use this option and I will be able to bypass the problem in the RAM without any additional actions. Also, what we have here, we have ability to bypass different kind of LED issues like LED, which was related about media cache fail, or another option, another issue with the firmware, and also we can skip some unnecessary update of the internal microcode. Yeah, these options could be selected in the patch. So depending on the case, you may decide what exactly to add into your patch system, into your modification of the ROM. So right now I will use this option. I press OK. And what I need to do right now, I need just to write the ROM to the drive. So right now ROM is written. I can repower the drive. And let's see how it will work. As you see, also we have Tecna unlock patch here, and also we have additional option to bypass divide fault state right now. What I need to do, I need to send unlock command, and let's see, drive is getting ready state, but there is no any DWF issue anymore. Drive gets correct ID. I can try to initialize the drive without any problems. I can read the service area of the drive, and of course I can deal with the user data right now. So the problem is already solved. It's enough to use this option to start working with the drive much quicker than before. I think you enjoy this option. And what else I can show you? A few simple but important things. First of all, when you create the backup, on Seagate, previously you may get the problem when, for example, you could rewrite the native backup if you do it twice. Yeah, for example, you had the original backup, and then after several days of work, you may by mistake start a backup again, and the native original files will be rewritten. Yeah, right now, if you do the same, you will get the additional warning messages like on a Western Digital drive, what to do with the exist file. You can overwrite, skip, or rename. That's very important and very good thing right now available on Seagate drives. And another small options which I want to demonstrate you will be related to the switch of the reading mode of system file. For example, I'm selecting system file for heads test just in case. Right now, as you see, ATA direct mode is selected. If I try to perform any actions here, if I try to write something here, I can see that my changes are not applied. It's not because of bad conditions of the heads. It's because this drive Rosewood A5 cannot write system files in this mode. Probably you remember about it. And if you want to switch the mode, you can double click here, select SATA indirect mode, and start and do the same. So as you see right now, result is different. Also, of course, it's possible to select terminal. It's possible right now to change the terminal speed for accessing the system area. That's why it's much more convenient dealing with the most complicated cases. Actually, that's all I wanted to show you about Seagate drives. And what else? In this update, I will not show you new features about CCB architecture, but of course, it doesn't mean that nothing was done. I can say that our developers made a great work regarding these drives, and they created a big library of different internal factory error codes, which right now allows to understand much more possible problems working with the drive to decide what exactly necessary to do with them. So we have added them to the new version of PC-3000. So I hope working with CCB drives right now will be more clear for you and more convenient. Yeah. And the second part of this video, I want to discuss Western Digital, of course. For Western Digital, I will use this drive. This is non-SMR Western Digital Black, and the example which I want to show you is possible to perform on SMR drives, and actually it's possible to do with different drives with different cases. What I wanted to show you. First of all, let's have a look on the behavior of the drive. I'm plugging the drive to the portable Pro and sharing the screen power on the drive and waiting for the ready state. As you see, drive is not getting ready so quickly as it should. It means that probably something is wrong. And when I start the WD Marvell utility, I can see the drive is not detected. The kernel mode here is selected. So I press auto detection to find the correct family. It's Makalu, and press start. As usually, we recommend to pay special attention on the utility log, so you can see that there is some kind of issue in the power up log related with the permanent overlay. So permanent overlay is an important part of the microprogram of the drive. So if it's not uploaded for some reason, drive cannot give you the access to the modules. Usually it happens because of physical problems or corruption inside the loader. And what to do in this case? First of all, you remember that for any case when you have no access to the service area, it's recommended to perform service area block. I will block the service area shifting the regions the common way. Then I need to repower the drive, and then we have to upload the loader and modules directory. You can try to use the donor resources, or if you have previously taken original backup, it of course recommended to use it. I will use the previously created folder for this drive, but actually if I have the compatible loader, it's also will work the same way. So I'm going to the modules subfolder and upload the loader and the modules directory together. Then I need to switch to the normal mode. Switching to the normal mode, I will get ability to check the service area copy. So I'm going to the modules directory, and just to confirm my words about permanent overlay, I can perform the checking of the service area to recognize which modules are in good conditions, which modules are not in good conditions. This kind of situation is very popular in real life, yeah, because of some head degradation, because of other reasons. Some part of the modules could be logically or physically corrupted, and because of that, initialization of the drive will not be possible. So, as you know, the critical level of the modules is very important, so we always take care about A and B modules. And for example, here in the B group, I see the overlay module number 11 is not readable, it's damaged, and another module is damaged. So what actually to do? Normally, we are trying to rewrite the modules. If possible, we are trying to reallocate the module on another position, but sometimes it's not possible because of big size. For example, if the module takes more than 1000 of sectors, it's complicated to reallocate it. For example, in this case, we cannot rewrite, we cannot reallocate the module. What to do? In such situation, actually, you probably know the trick. You can just send the warm reset to the drive if other parts of the modules, if critical part of the modules are okay. Actually, after HDD ID refresh, you will get the correct password of the drive, and actually you will get access to the sector. This kind of solution actually is well known, yeah, and it's not a know-how. But what I want to say is that, of course, the main work here starts in data extractor, because in data extractor sometimes we got the problems during the imaging. If drive will be, for example, restarted, it will be necessary to perform their actions every time from the beginning, and it's not really convenient way. Not really convenient way, because the solution which I show right now is temporal. So it works until they are repowering on, until the drive is stuck in busy state, for example. Right now, as you can see, it's working well. It's working well. It's possible to clone the drive. Yeah, but what if, for example, drive is repowered? Of course, it means that necessary to upload the loader again. And actually, it's possible to do automatically using the special scripts. Yeah, these scripts appear in PC-3000 software many years ago. Yeah, but in new version of PC-3000, developers added some new things here. And one of such examples I want to show you. So I want to select the active utility actions in error handling group, and I will use the special script which already was prepared here. And this script is not complicated. It's not complicated because it uses the same actions which I showed you before. So we repowering the drive, uploading the loader, uploading the dir to the RAM, performing reset, and reread the drive ID. What's crucial moment here is that we use this option like check static module data. It means checking if the drive is working well. Is it initialized or not? If it's not initialized, that options will be used. If drive is initialized, of course, it's possible to do without any additional actions. That is the script which I will use in this case. So when I press OK, when I press apply, I can try to continue imaging, and let's see what is going on. So check of static module is in fail. Yeah, that's why drive will be repowered. And right now, as you see, already drive is reading. Drive is reading. It's super fast and super useful thing for such cases when you have to applied RAM solutions. It's just one of possible examples. Of course, there are much more possibilities for SMR drives, for example. It's possible to use different ways of unblocking using the script. So if you have such complicated cases, if you don't know how to use the scripts, you are welcome. You can ask us in technical support. We will help you to work with your drive efficiently. And to work efficiently, there is another option which we have in PC-3000 right now. This option is to create the map of folders, map of files, not using the heads, but using the cylinders. Using the cylinders, how it may help you. First of all, let me try to select something for you. First of all, I need to select some part of files, and I need to create map of folders and files. Here it's some small size, of course, of data, but actually it doesn't matter. I'm just doing it for saving some time. And then the option which we have right now is to create the map using the cylinders info. Using the cylinders info, it means using the physical parameters, physical addresses of the sectors, which will help you to understand where exact file, where exact blockchain is located. Yeah, for example, if you are working with some kind of physically damaged drive, it could be important because you can understand that some part of the surface is dangerous to work with. That's why for each part of information, you can understand the real location. Yeah, the real location, and you can decide, is it good for you to read this part of user data, or maybe it's necessary to skip it and start reading of another folder or another part of user area. This operation takes some time. It's not working very fast, especially for the drives with big amount of data. Yeah, that's why it's necessary to wait a little bit. After this procedure will be finished, we will see the additional notes about the files. Let's wait. Okay, now as you can see, it's done. So right now, if you press on the sorting of chains of addresses, you can see the information not only about the head, but also about the number of cylinders, so can approximately understand where exact part of information is located. It's help to avoid working with the drives with scratches or some damages, and helping you to get best possible results. And not only on Western Digital, both types, SMR, non-SMR, but also it's possible to do the same on Seagate drives also. And I want to show you one more thing, that for some cases we got complaints about the RAM head map reading, and our developers successfully improved this mod. As you see, it was a little bit redesigned, but the main thing that it works right now much more stable and better in different cases. So you can try and hope you will get good results with it. Also, I can say that our developers made a huge work of to make work with USB drives more convenient, and it's possible right now to work with USB SMR drives and build heads maps there and create a different type of task for PBE access, for logical access. So full list of available things you will find in our change log. Yeah, so I hope you will like it. If you have any questions, we will be glad to help you through the technical support. So thank you for your time and for your attention, and bye-bye.
Okay, so welcome back for SSD part, and now we are going to talk about what's new appear in PC-3000 SSD. And of course, probably some of you already know that our developers were busy with Maxio controller support, and in previous software update, in February software update, we bring a pretty complete support for Maxio MAS 0002 model of controller, which is actually the same as Alexa DM918, and this update also bring extended support for new generation of this controller, which is Maxio 1102. I'm sure that most of you were waiting for a complete solution for this controller, because in our technical support we receive a lot of requests for this SSD. Usually this controller 1102 is very popular, and you can find it almost in all type of solid state drives produced by different brands like Hikvision, like AData, like Apacer, and some other brands, of course. And our solution will bring a complete support for the following memory chips. So if your drive is based on these NAND memory chips, I'm sure that we can get a pretty good result. Of course, our developers still working under this utility, and they improving the support of the NAND memory chips. So we're planning to extend support not only for YMTC, Intel or Micron memory chips, but also for some others like SanDisk, like Toshiba. But unfortunately, these drives are not so popular. Usually, Maxio drives are based on Intel or Micron memory chips, sometimes on YMTC, and their support become implemented on a very high level. So what do we get here? Actually, I've got a drive like this. This is a 2.5-inch SATA Apacer SSD with 512 gigabyte capacity, and this drive is based on Maxio MAS 1102 controller. And right now, let me share my screen, and I will show you what we can do with this drive, how we can diagnose it, and how we can try to recover it. First of all, we need to remove the drive from the cover, and after that we have to launch PC-3000 portable, and of course we shouldn't forget to connect the drive to port on our portable Pro device. And here it is. So we can launch the power supply on this drive, and we can see that this drive stays in busy, which is actually one of the most typical problem which appear with this SATA drive. So what we're gonna do in this case? First of all, we need to follow by utility selection and find Maxio controller. We shouldn't care about the busy status because we're going to short this drive later. And here we need to choose the Maxio controller. So let's switch to controller name, select our MAS 1102 family, cancel the initialization, and now we need to select our controller right here. Usually when we are working with this controller, it's recommended to short using the tweezers J2 points which are located on the drive PCB. But at the same time, we can try to do alternative way. We can try to use the terminal 5, and terminal 5 contains a special switcher, so we can use the wires, connect the terminal with our SSD drive to save point, and after that we can send the command to short the drive when it will be required by software. So let's go into utility extensions and choose extended mode. After that, we need to find our target profile. But again, let's imagine that we are working not with the Pacer drive where we already got the target profile, but let's example we are working with some kind of unknown MAS 1102 drive. What we need to do in this case? First of all, we need to choose one of the profiles for this MAS controller and choose some random profile. After that, we need to set the number of channels and number of chip enable to just a single channel and single channel map. After that, we need to type the correct empty memory chip and channel map. It's very important. And after that, we need to read the chip ID to make sure that we will choose the correct SSD profile. It's very important, because if you will miss the chip ID, or if you will miss the map of channels, map of chip enable, probably utility will not work correctly. So that's why if you are faced with unknown drive and you don't know who is the manufacturer of the memory chip, just try to set it like this. Use the terminal 5 to short the drive, or you can use the tweezers as I mentioned before, and press upload. And now our software will do the rest. So it will automatically switch the drive into safe mode, and after that our utility will try to load the loader and initialize the drive. We need to get the chip IDs to understand what kind of memory chips do we have here. And you can see that initialization goes further, and we got here the chip ID, everything is fine. You can ignore the information that memory chip is not into database, because actually these IDs be not initialized for now, and we need to correctly set the channel map to read them normally. That's why we can try to do the following thing. First of all, we need to read the chip ID to find out what is our ID map. So we're going to create a new profile. Oops, not here. Sorry, it was a misclick. I need to read the chip IDs. So we are going to read the chip IDs. And here we can see our map. So we got 2 channels, and every channel contains 4 chip enable, number 0, 2, 4, and 6. And we can use this information to form our utility. So what we are going to do next? After that, before we starting the initialization process, and before we starting any other procedures here, we need to find the chip ID, and we need to find the real name of the memory chips, because actually all NAND memory chips have 3 names. They have marking on the memory chip cover. Usually this marking going to be written on the factory. After that, we got the chip ID, the, let's say, passport ID of this memory chip, and we got the manufacturer code, and we need to know this manufacturer code. And to compare the chip ID with the manufacturer code, we need to follow to our profile on our computer. So we going to do it like this. We can follow by tools, explore profile folder of our drive, then goes to Maxio SSD, select MAS 1102. Oh, not here, sorry. We need to go to GPT folder, then 1102, and here we need to open flash ini document. which will contain all IDs presented in our software. So let me show it to you. And here it is. We got here the IDs, and we need to find which one belongs to our ID. So this is 2C. So probably this is the Micron chip. Then we got 2C, then S3, 2C, S3, going down, S3, then we go 08, here it is, 32, and here it is. This is a B47R chip. And we can try to find the correct profile in our software. And for doing that, we can get back to the extension mode, repower the drive, go to our profile. Probably we can find the same profile if it's already exists, but again, we can try to do it manually. So let's imagine that we got it like this and like this. So we know that our chips are B47R, we choose it. We know that the number of channels is 2, so we need to draw it like this, 0, 1. And here we need to type number of channels 4, because there were 4 channels, and we get it like 02 here, 04 here, and 06 here. And after that, press next. So our drive is in busy. We're going to use tweezers or terminal 5. So we're going to upload the loader and complete the drive initialization. Now it should read the drive ID correctly, the memory chip correctly. And let's wait till the end. Okay, so now we can try to read the ID one more time. And you can see that now all IDs reading fine and all channels available. Our drive capacity is almost the same as printed on the drive marking, because we remember that usually drive contains some external space on NAND memory chips. That's why 568 GB is okay for this SSD. So our next step will be the translator building, and for doing this we are using our default option, service information, translator, and translator building. So here we need to remember that MAS 1102 is using only PBT2 type of translator. So if you got one of this 1102 controller, don't forget to choose PBT2 translator table searching. There would be also PBT3 in the nearest future, but right now in this version we got just 2. Also, we need to choose the size of L2P record, and usually I can say that if your drive is pretty small, like 128 GB or 256, it should be 4096 bytes. In case if your drive is around 500 GB, it should be 8192. And in case if your drive is larger, like 1 TB or 2 TB, you need to use record size like 16 or 32,000. In our case, it's a half of terabyte, so we're going to use this one. All other things we need to leave by default, so we don't need to care about the plans count, subblock size. Better to leave these details by default. And after that, we can start the searching process. And now we can wait. Actually, I can say that the translator record, translator tables record searching takes some time, and probably for high capacity SSDs, this process may take more than probably 1 hour. Probably you will wait 2 hours, probably even more. But unfortunately, the reading speed of SSD drive, which located in technological mode, isn't so high, and we should be patient enough to wait till the end. So let's make a short break and wait till the end. So here it is. after some time, translator tables become readable, and we're able to see the final result. Actually, if you see that some numbers of these tables doesn't have versions, it's not a problem. It means that probably these blocks are empty. But in general, the rest of the blocks are reading fine, and we can see that along the complete dump, all records located at correct positions. And now the last thing that we need to do, we need to build the translator. So we press on build button. And now we should wait when the translator building will be complete. Actually, the translator building doesn't take as much time as translator table searching, so you can see that it's already been over. And now we can go to data extractor, make a new task. Let's call it Maxio. And choose our drive here, make data copy. Destination drive is an image. And actually, that's all what we need. And let's see what we get here. Instead of the Explorer selection, we can try to choose map and read, for example, a master boot record, which should be located at sector number 0. And we can see that master boot is reading. We got here the signatures, that everything is fine. We can type some random LBA and see that, yeah, actually it's working good here. And of course, let's switch into Explorer. And here we can expand the partition tree and see what we got inside. And actually here we got the user data partition. Here it is. And yeah, you can see that data is readable now. So actually, that's all for current controller. The Maxio controllers are very popular, especially this 1102, because we get a lot of requests from our customers. And please don't forget that in case if you get any problem with the drive initialization, you always can contact our technical support, and our engineer will guide you what you need to do to receive the data. But now we completely recovered this drive, and let's move forward. Let me continue with the USB utility right now. And actually, one more thing about the Maxio controller, please don't forget that Terminal 5 could be very useful, especially when you are working with this Maxio controller, because you can short the SSD drive by utility command, and in case if you need to release the shorting, you don't need to move to your office, take the tweezers, remove the tweezers from the SSD, then short it again. Everything will be done automatically using the Terminal 5. So the next case that I'm going to show you today will be Hewlett-Packard HP SSD drive. It's a portable SSD, and the interesting thing is that this SSD is based on USB flash controller. It's not a native NVMe or USB controller. It's a native USB flash controller, the same as usually we are solving using PC-3000 flash software using the chip-off method. The main idea of this controller is that it's Silicon Motion 3282P, and this controller you can find in portable drives like mine, like this tiny HP portable SSD, or you also can find it in some USB flash sticks. And again, as I mentioned before, such drive is possible to solve using the chip-off method and read the dump using PC-3000 flash, then reconstruct the file structure. But actually, our developers find the way how we can recover this controller using the technological mode. But the main problem is that we didn't meet a really non-working Silicon Motion SM3282P SSD in real life. So right now the utility for this controller being added in test mode. It's already presented, so we can for example, we can rebuild the translator, we can check the memory chip IDs, we can do everything with this controller as usually we can do with NVMe and SATA controllers. But at this moment, again, as I mentioned before, we didn't get a real case. So in case if you got any of these controllers, like in the real case, it will be very interesting to see how we can recover them. But again, this controller is already supported. Also, please don't forget that our developers already add the USB utilities, especially for not native USB SSDs like we support before, but also for SATA and NVMe SSD, which using the USB bridge on board. And such drive like Transcend, like HP, like Kingston, they already been added. And actually, if you will meet any of Silicon Motion based drive or Phison PS-3111, don't be afraid, because we can recover this SSD without the board modification, just a direct USB connection, and after that you will get the data. And of course, probably you remember that our colleague George make a pretty good webinar about the native USB SSDs. This webinar take part in March 2026, but as far as I remember, this webinar should be also uploaded into our YouTube channel. So in the nearest time, you will be able to watch the whole webinar. It's pretty interesting and could be very useful. But let's get back to our SSD. So let's connect it to PC-3000 portable. We are going to select any of this controller, because actually this HP rebranded SM3282 controller is the same. So let's make power on, launch the drive utility, and here we will need to initialize this controller. So here it is. And we can see that this is a tiny 128 gigabyte SSD based on Micron chips. And the cool thing that it's not SSD controller, it's a common USB flash controller, but you can find out that even such USB flash controllers now could be recovered without the chip off. And it will save your time, it will help you to focus on the data recovery on the higher speed. And of course, you should forget about the problems like dynamic source, like data compression, like block sorting, like ECC correction and rereading. Everything will be done automatically using our utility. And again, we get here a few options, like, for example, we can try to save the dumps from this SSD and try to reconstruct the image using PC-3000 flash if you want. We can make a memory chip test. We can rebuild the translator and actually do the rest of commands that usually we apply for damaged SSDs. And it's really amazing. So let me start the translator creation. Process may take some time, so let's make a new profile for this SSD, and now let's wait. Usually translator building doesn't take too much time for this tiny 828 gigabyte drive. Okay, so translator is almost finished. It takes around 7 minutes to complete. Okay, and here it is. So USB flash controller, but SSD approach. We're going to utility. We are making a new task. Let's call it SM282P. Here it is, and press next. Of course, this SSD is fully live. It doesn't like translator corruption or like busy status, because again, we didn't meet unworking controllers like this. But you can see that we already prepared for such cases, and in case if someone will ask us to recover similar SSD, it will be possible to use our new method and get the data. Okay, and again, we shouldn't forget about the USB SSD support, which are using the USB bridge on it, like S-Media or some others. And now you don't need to modify the PCB, just use PC-3000 Portable 3 or Portable Pro, and use the USB host to connect SSD directly to USB without any SATA or PCI Express modification on this SSD. So it's very, very convenient. Of course, in the future, we are waiting for some other solutions for similar controllers, for similar USB controllers, which may use in portable flash drives or in portable SSDs. So let's see what we will get during our future update during the next few months. And of course, I'm sure that something interesting we're going to show you during the ASLab Tech Week conference in Spain during this year. And regarding the USB drives, we already add the new Crucial X10 family. This drive contains some new features inside. And unfortunately, previously, when we tried to use our loader, when we tried to rebuild the translator, we faced with a lot of troubles, especially with this model of SSD. But in current update 7.9, this X10 model get complete support, and now we can recover 4 terabyte capacity models, and this drive is fully supported right now. And again, don't forget to use our SSD initialization method. I'm going to talk about it in our next part, in case if during the data reading there are a lot of black sectors. So new method works really great. Okay, so we did talk about the USB SSDs. We did talk about the SATA SSD, what's new we got. And of course, we shouldn't forget about the new loaders, which appear for SATA-based SSDs. But now we are going to focus on NVMe drives. And I could say that this version of PC-3000 brings a really, really useful and critically cool feature, because right now you can recover a lot of SSD drives which were not recoverable before, even if they based on supported controllers. And actually our solution was added for Silicon Motion SM2263XT and for Silicon Motion SM2320G USB controller. What was the problem before? Actually, you know that the success rate of SSD recovery depends on what kind of memory chips are installed on the SSD. And usually when we are talking about the support status of SSD, we are talking about the controller name, firmware version, and NAND memory chip type. Who is the manufacturer of the NAND memory chip, like SanDisk, Toshiba, Kioxia, or probably Micron or something else. And sometimes our loaders were incompatible with some of the memory chips which were in use with already supported controller. Especially such problem appear on Silicon Motion controllers if they were made on this pretty popular SM2263XT controller. Let me show it to you, like I'm talking about this model. And we got a lot of requests in our technical support when, for example, controller was supported, but the memory chips were based on Samsung. So our loader was not made for Samsung, or probably on unsupported Unix memory chips or unsupported SanDisk memory chips. But now we found that actually it doesn't matter what type of memory chips were in use with your drive, because we can try to use the new feature which called the SSD initialization. What this feature can give to us. Actually, when we load the loader and when we build the translator and after we trying to read the data, if the memory chips are not fully compatible with our loader, usually we get a lot of bad sectors. And these sectors are not reading well. We are facing a lot of troubles connecting with the data quality. So we need to hit the memory chips. We need to cool them down, do some other things. And of course, this process will take a lot of time. And instead of it, we can try to initialize the SSD, which will allow us to read these bad areas using the internal read-retry. This method works pretty simple, but before I will show it to you, let's check how the drive will work if it's based on unsupported memory chips, which result we can get in this case. So we got here, if I remember correctly, this is a King Max SSD, and this SSD stays in busy when I launch the power supply on the SSD. But again, I already connect the terminal connection. We can use tweezers to show it in safe mode, or we can use terminal 5, because right now, starting from this 7.9 software update, all controllers like Phison and SM, they fully supported the terminal 5, and you can use it to control safe mode on connected SSD. So let's launch the utility for our controller. ID is not reading because the SSD stays in busy, but we will try to use the shorting automatically by our COM port, and we are going to select it. So the terminal become switched our drive automatically in safe mode. I didn't touch the tweezers, it's very comfortable. And now let's see which memory chips do we have here. And you can see that actually the memory chips are YMTC. This is a pretty good quality Chinese memory chips, and these memory chips are amazingly popular right now between this controller and some others. But again, existing loaders, we have only for Unix chips, generation 6, and Intel and Micron chips, but not for YMTC. If I will try to load the loader, of course, it will be possible to partially get access to service area and probably even read the service area blocks, but the reading quality will be awful. And of course, the complete data recovery will be impossible here. So let me show you which result we can get here. And we can see that, okay, initialization was complete. We can try to use the chip ID test. And all chips are fine. The drive capacity should be around 512 gigabytes. And actually we got here 8 chips by 71 gigabyte each chip. But again, it's YMTC, which are not supported. So let's try to build the translator. And again, translator building will take some time. So we will get back to this case right after the translator will be finished. So right now our software is trying to read service area blocks to find the initial passport ID of this drive. Who is the manufacturer, what is the drive capacity, firmware version, and some others thing. And we got it. So let's press OK. Here is the model name of this drive. And translator being started to build. And now let's wait. All right, so it seems that process already finished. And it takes a really lot of time to build the translator here. And you can see that almost all service blocks become read with an error. And it happening due to the bad quality non-memory chips, and of course due to the impossibility to use the read-retry internally via our utility. So let me open the data extractor, and after that let's make a new task. So probably some data will be still accessible here. So we will call it like 63xt. Choose our drive. I would like to remind you that the NAND memory chips here are not supported by loader, so the reading quality will be really awful. Okay, so we can go to map and read 0 LBA, and we can see that, yeah, it's reading. And we even can try to open the folder structure here, partition structure. But as you can see, user data partition is not available. And if I will try to read or make a copy of this drive, I will face with a huge number of bit errors. Not here, but let's do it here. So yeah, some portion data is reading, but most of the sectors have black color, and unfortunately it's not possible to get a really good result here because data will be fragmented, most of the files will be damaged. Of course, you can try to use the heating, the freezing technique to get better result here, but in general I think that it will be impossible to get really working result with working files, because reading is not so good here. So what we can implement in this case? Actually, we can try our new initialization method. If I will close the data extractor task and then we'll return back to SSD utility. So I press test, drive mode, SSD initialization. Actually, this process is a little bit dangerous because we don't know why, but we found that one random block in this SSD will be erased during the drive initialization. This block could be erased on the empty area, it could be erased on the data area, it could be erased on service area, and even the translator tables could be damaged. We never know where this block will be erased. That's why it's a little bit tricky, so we have to warn you about that. But in case if no any other tricks are working, you can try to use this method. Of course, there is still a risk to lose the important information about the translator, but in my experience, I can say that we didn't get any dead drive after this initialization. But anyway, you should be very careful about it. So I'm starting the SSD initialization, and after that I will get a warning message about the possible problem, and we need to press yes. And now our software will make a resources backup from this SSD, will rebuild the translator, and right now, as I mentioned before, our SSD is connected via the it's shorted via the terminal, not by tweezers, but via the terminal. And it's good because our software will release the safe mode when it will be required, and then will short drive back. So again, process will take some time. Let's wait. And after some time during the initialization process, you can see that a drive read a complete passport. It's now available by logic, by physics, but of course we recommend you to rebuild the translator one more time because the access method will be here only due to the physical way. So we are launching the translator rebuilding one more time, and now we are going to read all service blocks with a read retry. And of course, the quality of translator building will be much better than before. And again, let's wait a bit. It shouldn't take as much time as before because right now controller shouldn't spend additional time for reading the bad areas. We are reading everything on the fly on a very high speed. So let's wait. Okay, so process is almost finished. You can see that the quality of translator building is much more high than before. And now I guess we get a pretty good result for data reading. And again, this new SSD initializing method is working for Silicon Motion SM2263XT SSD controller, and for USB controller SM2320G. These two controllers now can use this pretty good and pretty effective initialization way to read bad sectors which were not being able to read before. We are planning to add the same features for other SM-based controllers, but right now only these two are supported. So if you have some old Silicon Motion controllers based on SM2263XT without solution, which were based on unsupported memory chips or which contains a pretty lot of bad sectors on it, you can try to test our new methods. I'm sure that you will get a better result than before. And probably the main disadvantages of this new method is that it takes time because we need to save the resources backup from a SSD. Then we need to initialize it, rebuild the translator one more time, and so on. And one very important thing, please, if you are working with USB Silicon Motion 2320G controller, don't forget to make another resources backup manually. It's very important because in case of encryption, but you know that these USB controllers usually use hardware encryption for key generation, we need to get a complete resources backup. But if something will goes wrong with the SSD, when it stops working correctly, we may lose information about the encryption keys and their extraction will be impossible. So just be careful with that. But here we see that translator become built. We can go back to the data extractor, make a new task. We are going to use physical reading. And let's call it again like this. And let's compare the results between our previous drive initialization when we built the translator, but there were a lot of black blocks, a lot of black sectors with no good data on it. So opening the Explorer, and now I'm trying to open it one more time, and I can see that actually all sectors are reading well. There is absolutely no any black sectors on the map, and the quality of reading is very, very high. I even can try to do it like this, make use sectors map to show you that the process will go amazingly smooth. And we can see that this drive contains around 322 GB of user data, so we can start scanning process. And you can see that everything reading green, no any black sectors. And the speed also will be not so bad, around 5 MB per second, which is pretty good for that drive. So here is how this initialization method is working. In case of any questions, please don't forget to ask technical support engineers. Our guys will be glad to help you and give you advice about what you can do in case if SSD is based on supported controller, but unfortunately NAND memory chips are not listed here. All right, guys, that's all for today. We talk about the new SATA controller for PC-3000 SSD Maxio 1102. Now it's supported. We also talk about the Silicon Motion USB controllers, which get extended support right now, including the SSD initialization with a pretty good reading of bad sectors, which were previously been not readable. And we talk about the Silicon Motion SM2263XT modification of SSD controller, which allow us to use the new initialization feature and get a very, very good quality reading result, even if SSD is based on unsupported memory chips. I hope you enjoyed this video. please don't forget to ask our questions. We will be ready to reply you as soon as possible in our technical support department. So please send your tickets, send your requests, write the drives which were unrecoverable before. Now, I hope that the new version 7.9 will extend the list of supported drives and will help you to get much more data than before. Thank you for watching. See you next time. Probably we will meet you personally during the Tech Week if you will come to our conference. We will wait for you. Thank you, guys. Bye.